Мы слышим звук трамвая.
Да, извините, пожалуйста, с телефона сложно тут отключить и сделать. Коллеги, все, я включила трансляцию, поэтому у нас теперь запись будет, все нормально. Сейчас давайте я тогда студентов принимаю.
Доброе утро.
Здравствуйте.
Доброе утро.
Доброе утро.
Так, у нас еще Иван Александрович. Любовь, Сергей Геннадьевич, какой статус у него?
Да, я вот ему написала, жду.
Ага, хорошо. Тогда пока чуть-чуть ждем.
Да, хорошо.
Коллеги, студенты, проверьте, пожалуйста, есть ли у вас возможность демонстрации экрана?
Секунду.
Нет.
Нет.
Так, хорошо, сейчас тогда мы сделаем разрешение. Сейчас, секунду.
Коллеги, доброе утро.
Здравствуйте.
Да, я прошу прощения, что я так что-то долго подключался. У меня какая-то проблема с сетью. Я сейчас попробую. Может кто-нибудь начать? Я сейчас попробую разобраться и включусь тогда. Ну, полноценно, ладно?
Да, конечно.
То есть я здесь буду сейчас?
Так, все, мы возможность экрана демонстрации сделали, да, все видно?
Да.
Хорошо, окей. Так. Давайте чуть-чуть тогда подождем по статусу Сергея Геннадьевича, наверное. Или как?
Да, он подключается.
Подключается. Ну все, отлично, прекрасно. Okay, dear colleagues, it looks like now everything is fine from the technical point of view. Do you hear me well?
Yeah.
Great. Okay. So we still don't have Sergey Davidov here. Do you have any updates about him? So now we have Sergey here. Sergey, hello? So you're here.
Nice to meet you.
Great. Okay, so we are fine. So we have all of us here. And so then we should start the presentation, first presentation that we have for the defenses today. But before this, I will start the recording.
Okay.
Ivan Alexandrovich, probably you should say some words about the time and the flow of the defense.
Dear colleagues, nice to meet you here. And now we will start our defense session. And you have about 15 or 20 minutes for your presentation. After that, asking and answering time for your answers and for our questions. And after that, we will read reviews by your scientific supervisor and your reviewer. And after that, your final words. It will be good if we take to each participant about half an hour, and but we will act according to situation. Okay, you can start, please.
Okay.
Artemy and Roman.
Okay.
So good morning to all. I hope you can hear and see me well. Omar and me were writing about forecasting volatility of cryptocurrencies on the basis of an NLP analysis of Twitter's API feed. Sounds very complicated, but it was not that difficult. So our topic formulation, you can see it here. Our main objective was to write a program which takes tweets as input, computes the volatility, then a program which takes financial data about cryptocurrencies, aggregates it, and then after creating a common data set, which is merged, we built different models to check if there is a significant connection between sentiment in the market, which is extracted from Twitter, and the volatility of cryptocurrencies. So our goal was to create a forecasting model. In the end, we have created different forecasting models and compared them because we were not quite satisfied with the performance of each one with the data we had. And within the whole topic, it is difficult to create the non plus ultra model, which predicts it. So at first, we created sentiment analysis with the Veda algorithm. We constructed the market sentiment of the time series. We aggregated everything. We merged the data with the crypto time series and built econometric forecasting models afterwards. And we tested at first if the public sentiment has an effect of cryptocurrency price changes. The other hypothesis which led us through the whole scientific process was if price changes have an effect on the public sentiment, so in which direction is there a relation? And if cryptocurrency returns are predictable via changes in sentiment. So now I would like to summarize some facts about the Veda algorithm. We had to use the Veda algorithm because it doesn't require a lot of training. It's outperforming human raters, and it's not as computationally intensive like other state-of-the-art sentiment analyzer. And due to the amount of big data we had, over 100 gigabytes of text, we had to use a simpler sentiment algorithm because this was the only way we could handle the sheer amount. So in the end, the algorithm produces a valence scoring, and we get a value between 0, 1, and 1, and then we can say that like around 0, the sentiment is neutral. If it's positive, the sentiment is positive, and if the compound is negative, then the sentiment is negative. Due to the simplicity of the algorithm, it is not handling complex nuances or sarcasm in the text. It's not possible to differentiate between bots or real people, and there are a lot of disadvantages in it. But yeah, it's always comparison between the advantages and disadvantages. So the next step is the summary of the sample and the currencies we have used. After modeling our first typical gauge models and the more traditional econometric models, we realized that putting all currencies into one model is not working out well. The performance was not presentable. So we tried to differentiate between the currencies, and it made sense to differentiate between established coins, and Bitcoin and Ethereum are by far the biggest and most successful currencies. Then we have decided to also differentiate between the meme coins because they are in their behavior different compared to the other ones. They are much more volatile. The whole scene and subculture behind the meme coins is also different than compared to Bitcoin or Ethereum. And then we have pegged coins, which are somehow centralized coins which are regulated, and the regulators have always the goal of reducing the volatility, which is not always working out well. The literature review has shown that there is that other scientists have found a connection between volatility and sentiment of the market, and we wanted to show that in our data too. So yeah, that will hurry up now. So now we can go to some descriptive statistics and some visualizations. Here we see the sentiment. This is the black graph, and Ethereum and Bitcoin adjusted closing prices. Every variable is Z standardized, so we can show it on one plot. And we see that there is, in fact, it looks like there is a connection, because when the prices were falling down, the sentiment was also dropping very strong. And I would like to memorize this exact moment. Excuse me. Okay. Here we see that the sentiment was dropping very strongly, but the prices were not changing much. And this is one of the moments which makes it difficult to create a well-fit and good performing model. We see the same the same phenomenon in the meme currencies. The sentiment and the adjusted closing prices, which are standardized also, are like going into very different directions, and they are not very connected in this period of time. In addition to that, we see also like a drop in the sentiment is somehow connected and appearing simultaneously with a drop in the adjusted closing prices. Sometimes, not always. And we see a similar phenomenon with the pegged currencies. And this is also, like, again, this moment which made it very difficult to model a very good forecast. We have correlated the difference sentiment and the returns. The difference sentiment means that we have taken the difference within the data set between day 1 and day 2 of the sentiment and checked out the difference. We correlated it with the returns, and we found no linear relationship. We see that the correlation coefficients are very small. They are close to 0 in most cases. And we see definitely no linear relationship within these plots for every single currency. So now we know that it's difficult to model something with the sentiment and the price return variables, and we don't have a linear relationship. So these are the main facts we took from the exploratory data analysis. After doing Granger causality tests, we found that Ethereum and Bitcoin shows a significant Granger causal effect for 3 legs. There's a similar phenomenon within the meme coins, and the pegged coins didn't show the Granger causality as we expected. And this was also one of the reasons we have not modeled these variables in our later models, because there is no Granger causality, no significant Granger causality. Then we have created these 4 different models, and Roman will take over now.
Hello, colleagues. I would like to talk about models that we've used. It is also important to mention in the previous slide that while we did find the Granger causal effect of sentiment on the returns, we did not find any significant Granger causal effect of returns on sentiment. The other way around, which was the second hypothesis that we were testing. Okay, let's go back to the previous slide. As we mentioned earlier, we did not find any linear correlation between sentiment and returns. Therefore, we could not use the more commonly used for financial time series models, such as GARCH, ARIMA, VAR, that we initially planned to use. Instead, we decided to build the following four models: LSTM, random forest, polynomial regression, and convolutional neural networks, which are able to handle the nonlinear relationships. While there are other models capable of doing so, we decided to focus on these four. Okay, let's go to the next slide. Let's start with LSTM, or short long-term memory networks. It is a type of recurrent neural networks, which are networks able to build memory of time events by implementing, by having internal states at each time step. And LSTM is a type of such networks that are able to remember up to or more than thousands of these time steps by implementing a gradient-based algorithm that prevents exploding and vanishing of errors, which is a rather common occurrence in other recurrent neural networks. In order to prevent overfitting, we applied Keras Tuner. It is a tool provided by Keras library in Python, and it systematically goes through various combinations of hyperparameters and suggests the best ones. So here we used two legs of observed variables, 64 LSTM layers, atom optimizer, and ReLU activation function. We also divided our data into training and test in a 80-20 split. And let's go to the next slide. Yeah, according to performance metrics, the model does not overfit for Bitcoin or Ethereum. In other words, it performs similarly for training data as it does for test data, or I should say on test data as it does on training data. For Dodge, it shows some signs of overfitting since it performs better on the training data than on the test data. And for Shiba, it slightly underfits since it performs a little better on the test data than on the training data. Mean squared errors, MSE, are low for Bitcoin, but rather high for Ethereum and Shiba, and very high for Dodge. This indicates that there are some large errors in the predicted values versus the actual values that are being punished by squaring them. Let's go to the graphs. Next slide, please. Okay, so looking at graphs, we see that the model does capture some movement of Bitcoin and Ethereum, though not very accurately. For the meme coins, the performance is rather lackluster. Okay, let's go to the next model. Okay, next model is random forest. It is a technique which is an ensemble of decision trees that help reduce variance in the predictions by bagging or averaging outputs. And this method provides some defense against overfitting. This technique is most commonly used for classification and regression tasks, but it can be modified to handle time series by manually creating lagged variables, which we did. Next slide, please. Okay, performance metrics indicate the similar results to the previous models. Once again, the model does not overfit or underfit for Bitcoin or Ethereum, but it does for Doge and Shiba. Let's go to the next slide. The graphs also show similar results. While it does predict some trends semi-accurately, it is not very accurate, especially for large drops for Bitcoin and Ethereum that we see. For Doge and Shiba, once again, the model is performing rather poorly. Okay, next model is the polynomial regression. And I will let Artemi take it from here to talk about this specific model.
So the polynomial regression, after researching how to handle our nonlinearity, we also tried to build a NARCS model, which did not perform very well and was tricky to implement in Python, but we found that the polynomial regression might be a good fit to predict something. And so we decided for it. If you remember the formula of the linear regression, the polynomial regression has the same structure, but the independent variables have a power to them. So you can get some nonlinearity into the effects of the model. And we built two different polynomial models because we were not able to use the same parameters on the established coins and on the meme coins, because there was just, it's just not possible to do that and perform relatively well. And we evaluated the RSME, MSE, and MAE again. For test prediction and chain prediction errors, we did this also to somehow validate our data and to find, like, to make a good conclusion if we are over or underfitting. And the polynomial regression worked better for the established coins, showing a good model fit, close error statistics, and the meme coins are like expected, a bit more difficult to forecast because they are very random in their nature. So one of the more interesting steps we have done was the comparison of the, I hope you see my mouse, I'm not sure about that, but we have a test to prediction error and a train to prediction error for every currency. And if the test prediction error is smaller than the train prediction error, then we have a underfit, and vice versa. If this is smaller than this, we have a overfit. And we compared these the polynomial regressions. And have systematically changed the parameters to try to get these two values as close to each other as possible. We found that Doge and Shiba need a lower low-pass filter compared to the established coins, a cutoff filter of 0.1, and a very high power in the polynomial model. Which is usually not recommended in the literature, because the higher the power gets, the stronger the overfit could get. But the errors show that, yeah, we handled it kind of okay. At least better for the established coins than for the meme coins. Our predictions look like that. We see, compared to the other models, that the polynomial regression is getting much more movement into the prediction. So the prediction is finding more volatility than a random forest, for example. We also see that some moments are predicted very well. If you look at this point in time or at this point in time, the model looks kind of good performing, but there's a metaphor in German, even a blind chicken finds a corn sometimes, so we shouldn't expect too much from it, because in other moments, strong changes in volatility are not predicted very well, and they're also going to the wrong direction, and we see that this is not very well performed. But yeah, we have also found a even better way to predict it, which is also interesting, that a convolutional neural network, which is a very powerful tool, is doing it better than us when we try to model a gauge for a very long time. So we have also tried another validation of the models, and we saw this phenomenon that the 9th fold is always very high, which is bad, but it's repeated. It's a repeating pattern for every currency. So we know that the sentiment, because that's the common variable within, is in this time frame doing something very strange. And if you remember the visualizations in the beginning, there's like the sentiment and the prices are going into complete different directions, and even the system which we saw before that, and sometimes there was a correlation, in this point of time there was none of it. So that's the reason why our models did not perform as good as they could, and yeah, why the errors here are so big.
All right.
And,
Yeah, finally we have CNN, which stands for convolutional neural networks. These networks are most commonly used for image processing, but can also be applied to time series. This technique was inspired by the visual systems of living beings, and it's rather complex. But in short, there are several layers, each performing its unique specific function. So at the very first layer, the convolutional layer, a number of filters is applied to detect some specific features in the data. Then in the pooling layer, the number of parameters to be computed is reduced by applying a activation function. And finally, the fully connected layer provides the final output of CNN. Here we're using 3 legs of previous observations as opposed to 2. One convolution layer with 64 filters, ReLU activation function once again, and again we're splitting data in the 80-20 split. Let's go to the next slide. The model fits were good for established coins, while once again for Doge and Shiba it well, either overfits or underfits a little bit. This time the MSE is much higher for Bitcoin than previously. Let's go to the graphs.
Colleagues,
yeah,
please 1 or 2 minutes more, okay?
Oh, okay. Then let's go really quickly with this and go to the results. Okay, so but from the graphs we can see that some jumps are predicted much better than before, and while still not very accurate on the scale wise, the trends are being followed pretty well. Okay, let's go to the results really quickly. So we can have a few conclusions with the project. To start with, we successfully extracted the sentiment from over 100 gigabytes of Twitter data, turned it into a time series. We have also found that the relationship between sentiment and returns is not linear. We have seen the discrepancies between sentiment and returns in the last 2 months. We have also found that packed coins are not affected by sentiment, which makes sense when we think about it, because it's very unlikely that US dollar is affected by what Twitter users say about cryptocurrencies in the internet. So for the future, any potential future research, we have some notes to take. First of all, we have found that every coin might require its own individual model, or at the very least, its own individual set of hyperparameters. And while one model might predict one coin, semi-accurately, it will not predict the other coins. It is also very important to mention that predicting volatility is a complex task, and doing it solely on the basis of sentiment is not sufficient, and there are a lot more variables that affect returns. Yeah, so other than that, it is also important to notice that for the future research, it might be worth to use some other sentiment dictionary other than later, more refined for financial and cryptocurrency language. And it is also might be worth to invest more time and resources into choosing the Twitter posts due to large amount of bots and other useless posts. Okay, so let's return to the hypotheses that we were testing. That we were testing initially. Okay, so we did find that sentiment indeed has greater causal effect on returns. And interestingly enough, even though it might be somewhat counterintuitive, we did not find any significant greater effect of returns on the sentiment. Finally, like we just mentioned, while sentiment can be useful in predicting returns, it is not sufficient by itself and can be used in more complex models. But once again, the task of predicting returns on the sentiment is nearly impossible. Okay, thank you for your attention. We will be happy to answer your questions.
Yes, okay, thank you very much for your presentation. And now it's time for, yes, Stanislav, your question, please.
Yeah, good morning, everybody. Thank you for the presentation. It's very interesting analysis. Could you please go to the slide 11? Oh, no, it must be 10. Sorry, 10. Thank you. So when you conduct this exploratory analysis, and when you try to analyze how, as far as I understood, when you try to analyze similarity in volatility of sentiments and currency rates, when you found this difference, right? When sentiment goes down and currency rate goes up, did you try to analyze what happened at that moment? Because sometimes it's important to understand what external factors you may not take into account. And sometimes it could help you to maybe somehow optimize your model. Thank you.
Yeah. So this is closer to the end of the year, and we found that it is somewhat of a trend for it to behave this way. We did look into it a little bit, but then we realized that we're somewhat shifting the focus of the study, and it's not about sentiment, but about like external factors. And since the task was to, well, like we said in the conclusions, there are a lot of variables and things that affect returns or closing prices. But the goal of the study was to focus on the sentiment.
Yeah, sure. So when you say that it is trend, you mean that people tend to have high expectations in the end of the year, right? Something like this?
No, the sentiment is dropping.
Yeah, but currency rate is going up.
This is for pegged coins which are linked to US dollar.
Okay,
this is
okay.
maybe if you compare it to the previous two graphs, if you can go to previous slides.
Yeah.
And Bitcoin maybe. Yeah, it's not like
Not that much.
as big of a change. So cryptocurrencies behave differently to packed coins or like basically US dollar.
Okay, okay. Thank you.
And I would also like to add something to that topic. There is a connection between the movement of price changes and the sentiment, but the whole market and this whole subculture of cryptocurrencies is very is changing itself very strongly to external shocks. This might be that a South American country is accepting Bitcoin as an official payment, or it can be just a simple tweet from Elon Musk.
Elon Musk, yeah, sure.
For example, or the so-called dumping of crypto whales who are selling a lot of currencies at once and manipulating the market. So there's also a lot of centralized power within the market, and we cannot, with these models, cannot predict that. This, like Roma said, would go into another direction.
Yeah, it is like I also mentioned in the end. It is important to take into consideration for any potential future research that might attempt this task and implement sentiment in their analysis. But once again, there are a lot more things that affect this process.
Yeah, thank you.
Okay, thank you. Colleagues, do you have another questions? Not now. Now let me read the comments from your scientific advisor, Igor Koncharenko. Sorry, Igor. Is it here? Igor.
Yeah.
Yes.
Could you comment, or should I read?
I don't have the report on my hand now. I'm sure I can open it. Could you please read it by yourself?
Yeah, okay. Yes. In this paper, Artemiy and Raman studied statistical predictability of cryptocurrencies volatility using sentiment of Twitter data. First of all, Artemiy and Raman had done a good job of collecting large data set of 200 million tweets using Twitter API. Second, they developed for machine learning algorithms to estimate correlation of sentiment and historical returns. The paper has many practical applications since many crypto trading desks around the world start to implement automatic news sentiment into their trading strategies. Artemiy and Raman has found positive out of sample correlation between sentiment and historical returns. Artemiy and Raman showed good analytical skills and the ability to learn complicated material quickly. The paper is only the starting point, and much more work needs to be done in this direction. Overall, the paper satisfies to all HSE Master diploma requirements and deserves a good grade, resulting grade 7. Well, And we have another review from Ruslan Yusufov. He's a CEO of analytical company Mindsmith. The work contains a well-structured and fairly complete literature review. The methodology, data set, and analytical strategy are described and shown fully and correctly. It is especially important to note that the authors has applied a whole set of analytical methods to solve research problems. The interpretation of the result is correct. The conclusions are justified by the results of the analysis. And some additional remarks. I would choose USDT, those stable coins. Don't ask me what does it mean, but not USDC. In general, there were not enough selection criteria. Those mentioned, market cap, most talked, are not quite correct. The same, USDT has a higher capitalization. The second, there are small roughness and some screenshot applied. And the third, inconsistency in the presentation of the typology of coins. First list, then meme coins appear from somewhere so-called pegged. It's like a citation. Come out several times. The author should have given a definition once and not come back to this. In general, their work is strong, impressive amounts of data, extremely useful practical conclusions, and sign of fire. Okay, that's it. Dear colleagues, Artemy and Roman, you can answer for some comments, or you can
just for a little clarification, because Ivan Alexandrovich was a little confused about the inconsistencies that the reviewer has mentioned. To clarify, we had in some
I'm sorry, colleagues, could you give me the right to share a screen? Moment.
I don't have the option to make someone. Ah, okay.
Okay.
That's it.
Yeah, so I think it refers to a point in the text where while we gave an explanation of what pegged coins are earlier, later in the text we still said so-called pegged coins, as if it was not established earlier in the text, which is on looking back is somewhat of inconsistency. And I think, sometimes we put meme into asterisks and sometimes we didn't. I think that's what it's referring to. Yeah. If would you like us to say some final words, like you?
Yeah.
From the personal note, like I'm not sure what final words should include, but
thank you and goodbye.
No. I do have something to say. That while doing this project, especially at the moment of when we had to extract the sentiment from the Twitter post, it was very soul-crushing. I think we mentioned in the pre-defense the sheer amount of work that it included. We were really worried about if we could pull it off, but in the end we did. And then I guess during the analysis process, I was also a little bit underimpressed by the results at first, because I felt like, well, I had this picture of that we'll be able to predict returns just on the sentiment. There's going to be such a great discovery, but of course it's not as easy. But then after looking back at the work, I feel like it's still a strong work, and the results that we have found are indeed useful.
Mm-hmm. Okay. Okay, thank you very much. That's it. And your defense is over.
Thank you.
Finished. Okay, thank you. Thank you. And now we can move to another participant.
All right.
Valery Klimov.
Thank you, everyone, for
Nice.
attention. Goodbye.
Yeah.
Thank you. Goodbye.
Okay,
Have a
good
nice
luck.
day.
Good luck. Yeah. Valery.
1 second, please. I have some problem with this
Yeah.
audio.
We have
Few seconds.
Yes, we have time that it solve it.
Yeah, I'm ready.
Yes.
I'm so sorry. I'm mobile office.
Okay.
Okay. Yeah, you see my presentation?
Yes, it's okay.
It's okay.
We can see.
Okay.
Yeah.
I must turn camera, or can I off?
Okay. Okay. Sure.
Okay, I'm ready. Hello, everyone. The title of my project is Application of Advanced Analytics Technologies to HR Recruitment. In this presentation, I will provide an overview of the project that I have worked on during my master program. My original goal was to solve the problem of inefficiency in HR recruitment. Therefore, I will first formulate the problem that I will address in my project. When I will talk about two aspects of HR recruitment practices, what is known in academic research and what is happening in practice. I will then introduce my proposed approach to the HR recruitment. My approach is in domain format, which means it's based on a lot of practice of HR management that I will bring into this project with my experience. It is also data-driven, which means my approach will use advanced data analytics to address some of the limitations of current practices. Finally, I will present my approach and results of my work. All problems in HR recruitment can be broadly grouped into 8 major categories. The first and perhaps the most difficult one is attracting the right candidates. While it may seem similar to the second problem, engaging qualified candidates, these two are quite different. The company may not attract the right candidates for 2 reasons. If there is a misunderstanding on the part of the HR who the right person for the job should be, and if there is a misunderstanding on the part of the candidate what the job requires. So the first problem needs to be addressed from two different perspectives. On the part of the HR, there has to be the right job description for the functionality that needs to be filled. On the part of the candidate, the description of the functionality should be as close to their qualifications, skills, and abilities as possible. The second problem, engaging qualified candidates, can only be solved if the first one is solved. If the company understands who the right candidates are, and if candidates understand that the job will require of them, then finding the most qualified candidate out of a pool of all applicants is also a problem. Qualifications are often stated on the paper and difficult to verify. For example, two people may have identical diplomas from a computer science program, but one may be front-end developer and another a back-end developer. The person proficient in front-end development may not necessarily be qualified to do the back-end. Given how much there is to know about different job functions within a company, HR representatives are often not qualified to make the right decision. The third problem is hiring fast. This problem is self-explanatory. I think when there is a job that's open at the company, it means there is no people currently to do the tasks assigned to this job. Therefore, the work is either not done or delegated to people who already have their own jobs to do. So the sooner the vacant position is filled, the better. The fourth problem in HR recruitment is using data-driven recruitment. What does it mean? Depending on the company, there could be a lot of data available to properly formulate the job description and find qualified candidates. For example, such information, of course, is available at companies such as Headhunter that are placing tens of thousands of people into new jobs. Obviously, this data should be analyzed and evaluated using newest analytic method to find the patterns of candidate job fit. Unfortunately, most companies do not have access to the Headhunter data and have to rely on their own experiences, which could be severely limited. Even large companies, let's take Higher School of Economics, recruit certain position on a limited basis. When an accountant or lawyer leaves the HSE, the number of people that the new candidates can be compared to is very limited. Therefore, having enough data to perform substantial analysis can be quite difficult. Building a strong employer brand is formulated as the fifth problem of recruitment. I agree that companies such as Yandex or High School Economists, it's much easier to attract employers that it is for a small technological startup. However, this problem becomes a problem when the company is large enough. Majority of companies are not large, so that attractiveness of their brand is an employer is minimal and is unlikely to be resolved quickly in order to bring the next best candidate to the job. We have moved to the domain of employee-centered hiring. This problem 5 already. With problem 6, we are fully focusing on what each potential candidate would think about our company. This is entirely a company problem. It is HR representative have to be a professional now to present the company in the best way possible. There is so many horror stories out there that we know. Problem 6 is alive and well and not about to go away anytime soon. I think I've been talking about theory long now to take a break and look at problem 6 in a little more detail. Here the 3 stories that show that the problem 6 is not given anyway. Lilian asked, I was asked that my star sign was when I hastily replied. The interviewer commented that it's his son, that the same one. Awkward silence followed. I was once asked how much away, say Dimitris. I was asked there, I believe in love at first sight. It's a seemingly harmless question, but that does it have to do with the job? And would you ask a man what? Say Christina. Okay, let's move on. We are almost done. Problem 7 is recruiting fairly, which means not having a discriminatory practices in the recruitment process. I will not go into anecdotal stories, but I think we all know that recruitment process is far from fair. Finally, there is the 8th problem is of recruitment, creating an efficient recruiting process. Problem is nobody understands what efficient is. Moreover, companies have to invest substantial amounts in intangible assets in order to define and implement an efficient recruitment policy. This is not an easy process by any means. So we are now ready to formulate the problem that I will try to address in my project. Is it possible to create a solution that will help address all their HR recruitment problems simultaneously? I think that doing so is possible. However, to demonstrate the magnitude of that I'm about to do, I want to tell you a bit more about the attempts to solve this problem in academia and industry. Literature shows that there are close to 3 million of references on the topic of HR recruitment. Going through all the academic literature is infeasible even for an academic. 8 group of problems in HR were formulated based on the analysis of more than 100 references. Most of the articles address minor points in each of the 8 HR recruiting problems. The source there are the 2,600 existing applications. In practice, the problem of HR recruitment is being solved by creating recruiting apps. Many apps, I don't know how many there are out there. This aggregator that I looked at has over 2,600 applications. Some of them are clones of each other, some are unique, interesting, and now they again address only some parts of the HR recruitment problem. For example, some companies are only offering recruitment in a specific area, such as the accounting of information technology. Some companies offer resume evaluation services. There are, of course, job aggregators such as a Headhunter, but none of them solve all 8 HR recruitment problems at the same time. So my solution is to address all 8 problems at the same time. To do so, I have developed an application also. However, I took an approach not currently being used. This is because I believe that the secret to success is to implement a solution which is centered entirely of the candidate, not the company, the candidate. This is what I mean. First, a lot of application is all with psychological testing, but they do not create a full picture of a person or do not evaluate a person job fit. They mostly look for narrow skills or provide a very wide description of the person qualification. I have not seen an approach that will combine psychological testing result with resume and skills evaluation. Second, companies usually have a very generic job description that could fit a wide range of candidates. They selected the candidate and it more and may not the best candidate for the job. I do not know for any application that evaluate the failure rate or poorly placed candidates. They only show the success of placing a person for a job, but how they the person performed in 6 months or even a year down the road, they do not know. There is no follow-up on the reason why a person moves from one position to the other, at least not on the part of the HR recruitment application. Finally, I'm going to use lots and lots of data. Advanced in machine learning allows to incorporate many different variables into the evaluation process. Of course, there are many applications available already that do is artificial intelligence, but if you look closely, they do not address the first 2 points I have already mentioned. I do not know why this is the case. It is possible that I'm taking a very ambitious task that I would not be able to complete. But what is important here is the process, not the immediate result. But using the domain-informed data-driven approach, I will provide a lot of practical solutions to existing recruitment-related problems. My project plan was to develop a workflow of a proposed new application. This is an iterative process, and I started with MVP that would allow to start tracking user and collection data. I went back and forth between data collection and design steps. The main idea is to collect enough data to start evaluation whatever the candidate-centered approach is a workable solution to HR recruitment process. The proposed application in addressing all the problems that they have in depth through literature review and through evaluation of the application that the design is complete. It will address both the personal aspects of recruiting and the recruiting efficiency. All slides, this is our application. This is a prototype MVP. In this month, we start to development this prototype to MVP. You can look the flow when user come to our platform. Go to onboarding. Step 1, 2, the letter. The new app will start using our application ChatGPT to help user create and proofread their cover letter. It will also provide advice on efficient text building. Application-centered approach testing for individual differences. You can look. Personalized feedback based on validated test result, application reviews. The app provides personalized information and advice to job seekers. Consists on the application tailored to individual users. Matching psychologist type soft skill with job, and our platform now is make 2 tests, is REASEC and MBTI. When user is going this test, he can add this results of the test in his resume, or use this information for self. This is some demonstrate our flow. This is a future test. Next steps. This application required an elaborate approach combining state-of-the-art in several areas: psychology, HR, AI, and machine learning, software development, and marketing. The design addresses the major gaps in depth through literature review and comparison with existing applications. Next step, finishing the production of application test release to collect data, which will be analyzed using AI-based methods. Improvements to the application based on the initial feedback. Thank you for your attention. If you have questions, you can ask me.
Yes, Valery, thank you very much. Now we have time for questions. Colleagues, you can ask. Yes, Stanislav. Yeah.
Yeah. Valery, thank you for the presentation. I have two questions, main questions, I suppose. First question, our program devoted to the applied statistics and social network analysis. I want to ask you to what extent work which you present related with applied statistics and social network analysis.
We in the future, when we start the program application, we make marketing and come users to motivate, make a psychology test, because we have a free model to use to our users make his resume is better to the and this is this be a free methods to make his resume in our platform, and this is be motivation to make a psychology tests after the we make a big data, we are relevant with social media. This is we try this hypothesis in another our application is dating platform. Maybe know about us, and this is methodic is work when a user motivated to make psychology test, and after he has received a free resume with best quality, with best design, with best letters. I think this is work.
So, but did you access any models or algorithms which would be used?
We start. This is our second application. We now test this hypothesis with our first application. Maybe you listen about this is a Twinbee. Twinbee. This is a new dating service in the CIS. And we try these models to make psychology tests to our users, and this is working.
Yeah, and second question. So it's very nice prototype. It looks like somebody invested many hours in Figma to draw it, and generally UX and UI looks logical. So what is your personal input? What you personally did for this project?
Sorry, what is my personal input?
Yes, because yes,
sorry, I have a big company. I have a team, and we make this application with team. I'm a founder of this company.
Yeah, but
yes, and invest my family money to this project. This is not a prototype. This is a real business, and we make this application with in partners with High School Economy and the Rotterdam University in the United States.
Yeah, I see. I mean,
not a diplomatic work. This is a real business application.
Okay, so because we are here usually assess individual work of students, so that's why I'm asking this question. Yeah, thank you.
No, this is not individual. This is work with the team, and yes, this is project of my company.
Okay, thank you.
Okay, thank you. Yes, Igor, you can ask.
Ivan, why do you know that you will that your system will increase?
Not Ivan, Valery.
My
we
name Valery.
We have the same
surname. Yes.
Name. Yeah.
Oh my God! Sorry. Valery, could you please tell me why do you think that? Why do you believe that your system will solve any of the problems in HR that you stated?
I understand your question. We make many research programs to find these problems. About these problems work big team. This is a trend of the future to make to use a psychologist test and found your soft skills, your hard skills, and use soft and hard skills to be a better worker. That if you do not use a psychology test, because this is a problem in the future to mental health. And when a user starts make a psychology test, this is must be helped in the future to help them with big problems in the mental health.
Mm-hmm. Okay, thank you. And now I have to read the reviews. The first the first review it's from me, and the work makes an ambivalent impression. On the one hand, it contains a well-structured and fairly complete literature review, analysis of developments, and justification of the need for new solutions. And on the other hand, your own empirical research has not been conducted. Therefore, you did not have
Make your question by Russian, please.
No, it's not a question, Valery.
Oh.
It's just my words as a reviewer of your dissertation, and you did not have the opportunity to show the use of methods of applied statistics as and working with data, as Stanislav Moiseev asked. And the empirical part consists of description of the in-house development of the requirement application. And of course, this is an important achievement. This is a solution focused on solving practical problems. However, the question of its connection with the topic of statistical analysis remains open. It was the first review, and the second that it was made by Ruslan Yusufov, CEO of analytical company Mindsmith. My main complaint about the work is the lack of empirical research. It suggests itself. The author could analyze the market demands of market demand by taking a series of interviews with HR, and the study could be built an application test of or as a CGM, customer journey map. Without this, a well-executed literature review turns out to be weakly related to the empirical part, and the suggested grades is 6. That's it. And I think if we have no other questions from my colleagues, you can add some final words, and after that, your defense will be finished.
To my some words to my experience, this is not the first application we have started. When we start, we test hypothesis. We can make a very big pivot. Same dating, we have a free designs in the HR. Maybe this is a first design is good, but to my experience, maybe we make another application, but we must start it. After they started, after marketing, the users come, we focus group take CastDev tests, and after that we note that yes, the application is working. This is maybe in autumn we found that is good application. Today I don't know we make good or not application to the users. Thank you.
I see. Thank you very much. That's it.
Thank you so much.
And yeah, that's it. Your defense is over. Okay, and now we can move further. Maria Motsina, it is your time. Is she here?
Looks like not. Not yet, probably, because as I said, they think that they should come at exact time.
Yeah.
But she's coming. Maria is coming.
Okay, but we
yes.
have.
She's here.
But Maria is here.
Okay.
Hello.
Maria, nice to meet you.
Yeah, nice to meet you too.
You can start if you are ready.
Yes, okay.
You have about 15 or 20 minutes for your presentation. After that, we will ask some questions and something like that. That's our plan.
Okay. Hello, dear Commission members. My name is Motsina Maria, and I'd like to present you my master thesis of project type on theme of data management, building predictive pricing model based on variable sources. First of all, I want to start from a problem which I faced and why it was to examine. I'm working in Japan Tobacco International as pricing analyst, and I regularly face the necessity to predict pricing in market for different purposes. For instance, for estimation and prediction of share of market, share of sales, or in order to estimate our competitiveness in terms of pricing versus our competitors. And right now it takes a lot of time and human resources and efforts to analyze, systemize, consolidate different pricing reports, all knowledges that company has in order to build complete picture of market. And so therefore the main aim of considered case is to prepare a pricing predictive model based on theoretical knowledges about data management in order to optimize existing pricing reporting and make it possible to forecast and make data-driven decisions. And now there is a trend among companies to switch to data-driven decision making, especially for strategic decisions. And data-driven decision itself, its approach to make decisions based on actionable insights, based on real actual data, to extract some trends, seasonalities, to establish strong causations, and so forth. And numbers, like raw data, it's the main part of this process. So the object of this project is considered to be present pricing reporting system, which I would revise, optimize, and modify in order to build pricing model. And the subject is an analysis of possibilities, how it could be consolidated, transformed, and for creating multifunctional tool. Also on this slide, you can see my main goals. Firstly, is to determine data management approaches, assess existing report system, collect historical data in proper way as a basement for predictive model, and build the model itself. And before I move to methodology and the results of my project, I want to briefly introduce you in main aspects of tobacco market in Russia. By estimations of VCIOM, smoking incidence in Russia, it's nearly 1/3 part of all population. It's one of the most large values among the world. Also, if we look at tobacco and cigarettes production as FMCG category, 6 brands out of 10 largest FMCG brands in 2022 are presented by tobacco brands by estimation of Nielsen research. Tobacco market in Russia presented by 4 main players: JTI, Philip Morris, BAT, British American Tobacco, BAT, and Imperial Brands, ITG. The JTI is the largest company on this market, with its share of its brands nearly 36.6%. And additionally, I want to mention that as smoking incidence in Russia are really high, and smoking is really harmful for population health, government intervened in regulating of pricing of tobacco market, especially in pricing aspects. Were implemented several laws which influence pricing strategies. And a little bit about data management and which approach were chosen. Data management is an approach in generally how data collect, storage, processing, how it could be analyzed, and how knowledges and insights extracted from this analysis could be implemented. I considered to compare 4 most popular data management systems. Each of them has its pros and cons, and for my research, it was chosen a relational database management system. It considered data as tables with rows and columns, and relationships and connections are built on some universal primary key, which are implemented in each table in order that it could be combined. So moving to methodology, each step has its sub-points. And firstly, on the step of assessing existing pricing report, it was necessary to visualize how it as is now and how I want it to be. So how it will be optimized, modernized, and improved. And on the third step, it was collecting historical data, aggregating for further implementation of calculations and model building. And so the last step was to calculate and estimate the results. So here you can see how the process is as is was and how it's come after my project. The main weakness of as is approach as is reporting system, that it was well developed for analysis of traditional trade channel, and it was really poor analytics for modern trade channel. I want to mention that traditional trade is considered to include in itself some stores, some small points, tobacconists points, and modern trade consists of main retail chains such as supermarkets or local alcohol stores where cigarettes is also important good. So after my project, after this analyzing, I thought that it would be fair and optimal to create mostly similar approaches to each channel. So as for traditional trade pricing, we analyze existing reports and create some basement for future assumptions, for future predictions. And as well, something the same was was constructed for modern trade. Here you can see data sources which I faced to deal with, and the red is external databases which are collected by agencies, or for example, maximum retail prices declaration is one of government regulation, and it published online on taxes services. So all of them are connected with each other, and it's difficult to separate one of another, and they fulfill each other in order to make complex market view. And as you can here see, stock length for modern trade, it's a thing that I developed in terms of this project in order to make it possible to predict. So moving to historical data collection, as a historical period, it was chosen 2 years, 2021 and 2022. Main instruments which were used in order to combine it all, it was Microsoft Access, SQL language, as we have a deal with databases with a lot of attributes and a lot of rows and size, and Microsoft Excel as a final consolidation program, as most of reporting system and reports are presented in this program in company. And also for effective consolidation and interaction between these two programs, Power Query and language were implemented in the analysis. The basement level for aggregation was chosen subfamily. The smallest level is SKU. It's a particular pack of cigarettes, and subfamily are considered to group the similar packs by their pricing strategies, characteristics, brands, and so on. For traditional trade channel were developed a monthly aggregation, as well as for modern trade, because deliveries of these reports from agencies are split in smaller periods than 1 month. Also were created a lot of error tracking queries in order to prevent human factor errors and quickly understand where we can find some mistakes, and quickly repair it. Also for traditional trade, it was implemented smoothing method for price switching, as prices just do not switch in one moment. As today you have, for example, 100 rubles for a pack, and tomorrow you have 120 rubles for a pack in all our huge country. And the results were weighted on different levels. So in the model, we can split, and we can look into each channel on level of family, manufacturers, and price segmentation. And I want to mention this now, because further I will use this term. And for analysis, it was calculated most common MRP, maximum retail price for subfamily. As assumption, most distributed price in points of sales which were audited. As we find current price more than in 60% of points. And interim prices between one price and next price is 4 to 60%. As in subfamily we could have more than one SKU, we choose one of the largest SKU as main leader and trend maker. And for modern trade, it has its own specific. It focused on top largest 5 key counts and some other key counts with minorities and similar behavior as for traditional trade. In these key counts, we have a limited balanced SKU panel, so increase. So our coverage is 85 or 90% of total sellouts. And the main important aspect is that manufacturers tend to invest in these key accounts in order to manipulate with length of stock, how long price will sold, and maybe they could invest and in one time switch from one price to another. Assumptions for this data collection is that all SKU in subfamily behave as same as the leader one. For X5 and Dixie chance, we do not have sellouts distinguished by SKU and prices. So we based on data which agency provides us. And as well as for all traditional trade, monthly aggregation was developed, error tracking queries, and we added possibility to look particularly in each key account in order to extract some valuable insights on the level of key accounts. Here you can see the results of aggregation. So historical trends are really close to what we collected in terms of price model. And moving to forecast development, main assumptions which were put in the basement of predictions is that stock length for traditional trade is 2 or 3 months. It depends from manufacturer and it's based on historical data. Pricing assumptions for traditional trade based on existing reports. It's prepared by a separate group of people with their own expertise, and it's submitted with high management. So we take it as a given. Channel weights in total market are also given as a result of business activities in company. And other minor retailers with low share of sales are assumed to be generally in line with traditional trade, as well as provided by historical data on longer period. And talking about development on stock length calculation for key account, it has one formula: date of first time most common price became most common in key account, minus date of first time price was declared on the market in general, divided by 30 days in months. It looks quite easier, but it's not so in realization. It's necessary to also return to databases to establishing relationships, creating keys, and developing a lot of interaction steps. And one point for extra information that needed to be considered in stock length calculation and forecasting for key accounts is that we know that every manufacturer has some months in the year when they do some special trade programs for increasing of their volumes in this key account. Usually these key accounts are chosen as red and white and Bristol. Its efficiency of these programs are proved by many researchers. And so it influences on stock lengths as well. And as far as we know, when each company will establish their trade program, we could roughly estimate the impact of these programs on our company or on competitors. And so after the model were constructed for checking its accuracy, it was chosen for actual periods of 2023, January, February, March, and April. Firstly, after constructing first version of forecast in January and February, after getting actual data, it was compared with actual data, and we see some gap which do not go with actual data. So after that was reconsidered some approach to modern trade estimation. For forecast, it was added extra weights for each subfamily. Previously, it was estimated that it's not so necessary, and weight for subfamily were equal for each key account. And after embedding this adjustment, forecast in March and April were really close to actual data. And talking about business utility of considered case, it was tested on plan actual monthly reviews. It provides some great results. We could predict weighted average prices and prices index for total market in general and tobacco manufacturers in details. Previously, it was based only on traditional trade adjustments made by people based on their expert look and on their senses. Also, it decreased the time of processing and performing valuable results. It's reduced for total update and calculations for submission. It's reduced to 1 full-time working day instead of 3 full-time working days, which contains in itself detailed consideration of each report and each assumptions and so on. And in terms of mid-year strategic review and forward planning in company, it's a rule and policy in company. It's necessary to calculate different price scenarios to understand how we could move further in the future and what will expect us in case of one decision or another. And it makes possible to compute each scenario in 1.5 hours. So it's different of total updating because we change only pricing input, and other inputs like sellouts, like weights, stock lengths remain the same. And versus 3 hours.
Please 1 or 2 minutes. Okay.
Yeah, it's the last slide of my presentation. So yes.
Okay.
Thank you for attention. If you have any question, I'm glad to answer them.
Yeah. Thank you very much, colleagues. The time of your questions, please. Maria. Well, I'll switch to the reviews.
Hi, there is a hand from Sergey.
I'm sorry. Yes.
Yes, I have a little question. Maria, it seems that your topic is quite standard in terms of task, which is important and very relevant for many companies dealing with prices. But you are solving your task on the basis of quite specific market and quite specific case. Why did you select this case? What were the reasons? And do you see any features of this case, or there are no features and this model can be used for other markets?
Okay, thank you for a question. One of the reasons that I work on this market and I have understanding of this, but it's not the main reason. This market, as you said, it's really specific and it has government regulation, and it's really interesting to look how manufacturers compete with each other in terms of pricing. So, as for example, as leader, we could drop price. For example, for 10 rubles, and we could see the reaction of competitors, and we need to estimate how harmful it could be for us. And as it's regulated, and every manufacturer is obligated to declare the prices for production on the next month, on every month, it's possible to look on this picture and estimate. Such model have its own specific features, but it could be easily adapted for same markets. For example, for alcohol market, as it's also regulated by government, with some addings or adjustments, it could be implemented in other markets.
Okay, thank you. Well, Елена Стегни. Sorry.
Okay.
Okay.
Sorry.
Елена Стегни, she was a supervisor of your work. She wrote, Maria demonstrated high level of self-independence. That's why it can be conducted that the work was prepared by Maria herself without scientific advisor involvement. The topic which was chosen by Maria is up to date, and I can prove that there is necessity for similar work in business. starting from organization of data management and ending up with high-level predictive models to make data-driven decisions. The recommended grade is 7, and there are few comments to the grades. The structure of the work could be more specified, not just introduction, background, methodology, as it is normally done in applied report and academic articles. Research tasks are set rather well. However, based on the submitted work, it is hard to evaluate task 3, 4, and 5. How exactly there was the process of data collection, complicated or not, which programs were used, and which skills were applied, etc. The next one, data management concept could be described in more interdisciplinary way due to the fact that there is a great interest among scientists from computer sciences, managerial sciences, etc., as well as among practitioners. Moreover, the work is done as a case study for one of the companies from tobacco industry in Russia. Next one. From case description, it is not clear why it's a citation. The company is interested in forecasting weighted average price for total market for 3 full years towards the first year out of them needs to be split by month, page 14. Thus, it is unclear how exactly this work will help the company to become better. From description of the case, processing, data sources, etc., there is no clear logical and coherent link between empirical and theoretical parts. One of the tasks of the work was data collection. However, in case study, there is not much attention to that. Next, data aggregation could be supported by the schemes, tables, and concrete examples. And the last one, estimations, prediction models are not supported with any formulas, numbers, etc. That's why it is impossible to evaluate the analytical and statistical approach. And resulting grade is 7. It's more easy task for me to read Dina Yakovleva because there are no comments, and suggested grades is 8. That's it. And Maria, now you can comment and you can answer for the.
Thank you. One of main comments is that I really maybe I agree with Elena that I could add some more examples, tables, or details, but I'm afraid to lose key idea of project while deep research on this field and overload the work with details and some basic calculations. Yes, I tried to emphasize our main tools during the presentation. It was SQL and Microsoft Excel. In terms of if we're talking about comment about company strategic review necessity for 12 months, 1 year and 3 year prediction. It's 12 months for current year, as we could, as we know some inside information, and we want to test it and analyze from different points of view. And for 1, 2, and 3 years looking forward, it's a little bit frustrating future, but we need general trends, how we estimated to behave on the market. Is it estimated to grow, or to expected to decrease or stagnate, and so how we feel our positions on it. Yes, it's main comments for Elena review.
Okay. Thank you very much. And now you can add some final words, and on it, your defense is over. Okay.
Okay. Thank you.
Okay. Well, thank you very much, and that's it. And now we can move to another participant. Now, how it is?
Ivan?
Yes, hello. I'm here.
Ivan. Yes. You can start. You have something like 15 or 20 minutes for your presentation. And after that, the Q&A session.
So I have a question. Can I use my 2 accounts, because I have my scenario script on other device? So, and then first device I present the work.
I think
it's up to you.
Yeah.
Okay.
Yeah, we see that you have 2 accounts here, but for us it doesn't matter.
Okay, so I have 15 minutes, yes?
15 to 20 minutes. Mm-hmm.
Okay, let me start. Sorry, I have a problem. Please 1 minute.
Yes, sure. Mm-hmm.
I'm not sure if you do you see it?
Yes.
Do you see it well now?
Yeah, it's correct.
Mm-hmm. Okay, so the topic of my work is the optimal interest rate policy modeling, and we did it using the multi-agent based reinforced learning. So the the work is applied for the Russian banking sector. So we did this simulation with 2 agents and with the banking environment. Okay, so let me start. I would like to begin with the role of artificial intelligence and machine learning in banking and finance nowadays. So firstly, I would like to mention that the share of usage of machine learning is increasing recent years. So mostly the financial service sector, it is progressing. because new cutting-edge solutions are implemented. For example, financial institutions right now, they can turn the stream of data they regularly produce into useful insights for everyone. So businesses are trying to use machine learning cases in finance to improve security, to improve the user experience, and etc. So as I present here, according to McKinsey, the cumulative benefits are so great that the annual potential value of artificial intelligence and analytics for global banking might be as high as $1 trillion. And so we have here like a scheme, the distribution of usage of traditional artificial intelligence and advanced. So in two words, the traditional artificial intelligence is the simplest methods of machine learning, while the advanced AI is the approach used with deep learning, with neural networks, and etc. And what I consider as one of the most useful impact of applying artificial intelligence is that, for example, it can reduce the problems of false positive decisions, so which are sometimes made by the banks while the people, for example, are trying to make a transaction or get a response from the bank, and sometimes the algorithms, they work not so properly. According to European Intelligence Unit's report, so almost 85% of banks, they have a clear strategy for adopting artificial intelligence solutions. So mostly they invest in cloud technologies, in modernization of core legacy systems, and it allows them to deploy their machine learning algorithms for their business, and so on. As for this work, it is important here to understand what does influence on the banking system, on the role of interest rate in this system, and so we can see here a scheme of rising growth of the deposit rate and the central bank key rate. So how it happened during the last year. So, and to save time, I will say that mostly on the interest rate policy, it is affected by the key rate of the central bank of Russia, because it is one of the key players. So we cannot forget also about which of the bank to have a control under the interest rate, and for example, it cannot afford additional risks like savings in foreign currency, because it gets some sort of risks. So also net interest margin affects the interest rate of the bank. So what is the net interest margin? So it mostly reflects. It is so it plays a great role here, and is calculated using the special techniques. And we can say that volatility and size of it has a significant effect on the stability of the banks and on their decisions. So what is the most important thing here is that dynamic changes in volumes and incorporate in individual loans and deposits can be related to interdependent changes in interest rate, and it is reflected in my work. So we conducted an analysis here. So how the volumes of loans and deposits, what is the reasons? So when they are changed, and what is the connection here with the changes in interest rate the bank sets? And shortly about the research problem. Our research gives an answer to a question whether the bank interacting with virtual environment and seeing the previous decision of another bank can choose the optimal way of pricing strategy and decisions, making as much profit as possible. And as an indicator for making profit, we took the return of equity, so I will explain it a little bit later. And also as a reward function for the multi-agent reinforcement learning. And the second additional option is to find and conduct network and econometric analysis with unstructured data and complexity of combining the two analysis using available data. So, and the object and subject here, the object is the Russian banking sector, the subject is the problem of applying the derived financial parameters. So to the predictive econometric models we are developing here, and to set and complete the simulation to validate its results. The goal of study is to apply the subset of machine learning methods called reinforcement learning in order to create the more competitive model for banking sector. So we would like to prove and measure the influence of financial parameters on banks' interest rate, as well as to assess the bank's behavior based on learning from previous actions and financial conditions. So I prepared several tasks which we had to complete to achieve our results. The first task is conduct a comprehensive literature overview, choosing literature related to our topic. The second one is to choose the correct parameters for our model and set them, explain the game rules, the reward function, and then to prepare a Q-learning algorithm for our multi-agent simulation. Then we define and measure how the banking financial parameters may influence on changes in bank's interest rate as for the Russian banking sector, and we develop the model framework. So we determined the effective approach to the simulation with two banks, and we took into account the correlation of financial parameters and required components, so it would be shown a little bit later in the second part. And the last one is to conduct simulation and observe it and assess the final results. We have special limitations. The first is the availability and collection of data. The second one is limitations of computational power. Talking about the reinforcement learning, so I took several authors, but I mentioned only some of them here. So in several words, as for the main framework, the state of environment changed by agent's action in reinforcement learning, and the agent is assigned with reward. And we have a book of Bartow here, so which is called Reinforcement Learning, and there he explains how it works, beginning from the single agent approach. In single agent, we have a state, we have a time period, we have an action function, and a reward function. So firstly, the agent gets an observation from the state, then it chooses the way of action. It performs this action, and this action changes the whole system, and then the reward function starts working, and so it gets like a reward, and that's why the reward function has to be chosen responsibly. So in development of a multi-agent based reinforcement learning, so usability of agents to be able to learn on previous action, it's also important, and the state changed by common vector. So in multi-agent approach, we have also like a vector of actions, and then it produces the changes, and which lead to a reward for agent. So also we used the Q-learning method here, used it to compute the optimal interest rate. So here it involves the decentralized process of learning. So each agent may learn on individual observation history, and it can see other agents like if they are part of the environment. So this method, it allows agent not to consider the whole space of action and learn from the individual history. And it also can like constrain agent from choosing non-optimal strategy. And so which factors influence on interest rate again? So as for the concepts, I stated here price and strategy, which accurately reflects and acknowledges customers' value perception because it is really interdependent. So it also the main feature is that features of proportion between the volumes of loans and deposits, they play a really important role. So because banks, they must prioritize the optimization of their interest rate strategy by accurately reflecting and acknowledging customers' value perception. So the mistakes in this way, so it can force the client move to other bank, for example. So this research, it was performed using R language. We performed the sensitivity analysis here, and the results of it. So they were used to prove the interdependencies between the volumes of loans and deposits and the interest rate, and then it was used to conduct the multi-agent training and testing. What I have to say about the model specification. So the Markov stochastic game is so here used. It was used as a benchmark for this research. So we would like to set the parameters which we require. So we have here also states which represent the all possible configurations of the environment, and we are taking the elements of bank's financial report and transform it to observations. So the observation function, it consists of loans, liabilities, shareholder equity, and corporate and deposit rates. So at each time point of t, every agent has the option to make a decision regarding interest rates, which includes lowering them or increasing by 1% or keeping unchanged for the upcoming period. And so in the previous works, so related to my work, which I have read, so it was recommended to include the capital adequacy ratio to satisfy the balance sheet requirement, because without it we cannot judge about the banks like if they're sustainable to make such decisions. So as a reward function, we chose the return of equity here, and to choose it, we took several historical data, and we have chosen the range from 5 to 25%. This is the return of equity bank has to generate. Else the simulation for it would be stopped, because so we can also not speak on it like if he is successful in his business, and so on. So we have the time horizon here, the number of iterations, the learn rate here, and the discount rate. As for the computation of interest rate, we applied Q-learning here, the Q-learning algorithm. So this algorithm, it allows us to train the agents. It allows us it allows every agent to learn independently based on its own observations and actions without requiring centralized coordination. This approach also enables agents to make autonomous decisions and adapt to dynamic environments. So we would like to benefit from this fact that each agent, it maintains its own Q values and learns from its own experiences. We can say that a flexible and scalable character of Q-learning applied for our research can accommodate different complexities and sizes of banking systems. For example, it can be applied to simulate interest rate policies like we are going to be, and so on. So we have a Q function here. It is derived from the Bellman's function, Bellman's equation. So we have here a learning rate alpha, which belongs to 0 and 1, and we have a discount factor too to perform this analysis. So technically, we required two matrices called of we use them to conduct this analysis. And also we introduced also the all required variables here, and the variable of discount, it would be set to 1 in our research. So in this approach, mostly the agent, at a certain period of time, it carefully absorbs the rewards associated with each action, and then it is able to learn to predict the most favorable action. So when encountering similar environmental states. So if the agent makes some progress, we can systematically decrease the value of epsilon and reduce the randomness of actions, and like highlight the development of rewarding actions, so rather than extensive exploration of the environment. Here,
Ivan, 2 minutes, please, more. Okay.
Okay.
Something wrong with screen share. You just switched to another. Yes, I can see.
So may I continue?
Yes, sure, can you?
Okay, thank you. So as for theoretical basis for this methodology, I will fastly cover this topic, this part of presentation, and here you can see just the authors I used here, not all of them. So, but so whom I consider as the most important for banking system and for reinforcement learning. So you can see them here. And as for the relevant final results, so we conducted the sensitivity analysis here to check the dependencies between how the changes in interest rate, how the interest rate can affect the final volume of loans and deposits for certain banks, for the VTB bank and for corresponding bank. So, and as for here, we think that so results of this analytics. So it also includes the customer factor, the factor of customer behavior, because it also it defines the attitude towards the bank services and changes, and in a sphere of interest rate. And here we took the historical data. It was taken from the 2012 year until the 2022. So to ensure greater accuracy in the results, monthly interest rate are derived from each bank. So here, the sum of 1 month's most prime rate was calculated. So we use most prime here, data from it. And so we have, maybe I didn't show it. Sorry. Oh, sorry, because I have had there the description of variables side. I can't find it. Sorry, I have missed the description of variable slide. I will show it separately. Please 1 second.
Ivan, could you switch to some conclusions or
Okay.
final comments? Okay.
I just wanted to show the variable selection and the description. Okay, so I missed this slide. That slide. So here we conducted the sensitivity analysis, and I showed the most relevant results here, which I consider as to be the most relevant. So we conducted several regressions, one for the VTB bank, for the main bank, and then for the corresponding bank. So here we analyzed the interdependencies between the corporate loans, between the individual deposits, and corporate deposits, and so on. And here you can see that results show that the change in other banks' law amount is highly dependent on its previous change at the time. And according to statistics, we have the R-squared, which tells that only 16% of the variation of change in loan volumes can be explained by the previous values, and the difference between delta rates in the last periods. The second one is that changes in volumes of individual deposits are strongly affected by its previous change at a time period of T-1, and VTB and corresponding banks' interest rate increase in the interest rate is expected to result in increased cash flow. So the bank will just make a better revenue here. And here we have the performance of multi-agent approach. So we conducted 3 sessions to perform the MRL and the sensitivity of
It's time to yes.
Okay. I will cover the conclusions. So briefly, to gain a competitive edge and maintain market share, banks need to embrace analytical tools like reinforcement learning and artificial intelligence to enhance business outcomes. So we have a possibility to interpret a Nash equilibrium in a non-cooperative game where the agents have chosen their strategies and cannot benefit from deviating from them. So as I told in the very beginning, so both agents are capable of learning their optimal policies by considering information about their opponents. Although the maximum reward may not be achieved due to the complexity of the environment, a sensitivity model can be derived using vector autoregression function that incorporates previous values of explanatory variables and parameters from other banks. And the last one is that incorporation of additional macroeconomic parameters, such as inflation rate, unemployment rate, can be used to develop this model. And also the development of more Nash Librias. So I think that's all. If you have questions, you may ask. Thank you for the attention.
Okay, thank you very much, colleagues. You have the opportunity to ask your questions.
Sorry for presentations. 2 slides were lost, but I can send it to the chat maybe.
Yes, I understand it. Okay.
Probably I can ask a question. Thank you very much, Ivan, for your presentation. So the question is, so talking about the substantive results. So what can you say about the optimal interest rate policy? So can you make some suggestions according to the analysis and modeling that you've done?
To model it overall? You mean the overall conclusion?
Yeah. I mean, like what suggestions we can make to the banking system, to some bank or to the bank system as whole, according to the modeling that you have done, on the question of what should be this rate policy, interest rate policy.
So I suppose the current tendencies of implementing of artificial intelligence, it is really useful so to reduce the common mistakes so the bank can make so while working on its corporate strategy, loan strategy, deposit strategy. So so making more quantitative research in this sphere, the ways of development, so the bank can find using them. So I think it can provide the customers with better service so than they have now, and when the customers are more satisfied, so the policy of banking revenue, so it improves. So because the volumes are changing up to that.
Thank you.
Okay. Colleagues, would you like to add something?
Yeah, maybe just a brief question, just to clarify. Yeah, Ivan, thank you for your presentation. When you conducted literature review, maybe you have an opportunity to discuss your topic with some experts in the field, because it looks like you're saying that banks should use such AI algorithms, but it looks like they are already using some of algorithms, or at least for the last 5 years, to, for example, optimize deposit rates, credit rates, so on and so forth. Because at least I don't know, top 20 banks which we have in Russia. Do you have some insights what kind of algorithms, procedures, and models they are already having, or you just based your work on literature review? Thank you.
Okay, Stanislav, thank you for your question. So as for now, I'm not living in Russia, so I'm living in Switzerland. So, and I got some discussions with the professors from the University of Zurich. So, but as they are claiming that, to be honest, the technical development of the Swiss banks, for example, in comparison to banks of United Arab Emirates, to even Russian banks, so it is quite worse. So, but they have another situation with loan policy, for example, because the policy of balance of keeping this balance of giving more loans, so and trying to make more money. So it is quite not the same like in Russia. So for example, not so many companies and not so many customers can get regular loans, and banks prefer here not to invest too much money, for example, in the businesses and etc. So the banking system here, it is quite trying right now to, as the Swiss experts say, to reinvent itself. So because of the collapsing of Credit Suisse. So, and in that way, I think the policy of Russian banks is a little bit better, so in comparison with the Swiss ones.
Okay, thank you. And may I add some comments? It's not a question now, but it was before your presentation. I would like to know that your presentation is better structured and clearer than your text, because the text of your master thesis doesn't contain a section that consistently summarize goals, objectives, key research question, certain central problem, description of the research strategy, and so on, and that data collection process. As for me, it makes it difficult to assess what you planned to do and what was able to implement. And also I want to remark that master thesis contain very short and informative conclusions. It was like a short anecdote. The most informative suggestion or conclusion that our experiments demonstrate that both agents are capable of learning their optimal policies by considering information about their opponents, but there are some nuances, and so but in your presentation is much clearer the text. Thank you.
Yes, Ivan, thank you. I just I have nothing to add, so I just can mention that yes, it was my mistake, but so the goals and the tasks, so all of them were sent in research proposal. So I had several discussions, and so I thought that maybe it can be like sent separately. So, but it's my mistake.
No. The project proposal is the important part of your master's thesis. Okay, that's it. And now I can give the opportunity to say something by Igor Goncharenko.
Yes. Dear colleagues, first I want to mention just two facts. That one fact is that Ivan, I happen to be the scientific advisor of Ivan, but we've never met and we've never discussed the topic of the diploma. So it was I was caught by surprise when Ivan has sent me the final diploma without discussing the topic with me. And also the second fact that the data that Ivan used in order to evaluate the elasticity models and just the first look for the professional at this data, it doesn't seem correct. So it needs to be verified, and thus all the conclusions that he makes in the diploma has to be rewritten with when the input data is correct. But the third, listening to the presentation, and overall, the topic is very important. That Ivan has chosen, it's indeed very important, and it's very deep and has many practical applications. So just so these are three facts. But just even in the presentation, I have many questions and comments which I want to leave in private. So overall, that's all what I want to say.
Okay, that's it?
Yes.
Okay, thank you very much. And we have a reviewer. There are no additional comments, and the suggested grade is 9. Okay, that's it. And now your presentation and your defense is finished, and you can add some final words, Ivan.
Yes. So first of all, I have to say thank you to my supervisor Igor Goncharenko. So I just have to apologize that due to my specific family conditions, I didn't have a real opportunity to work normally with him. So, but I would like to thank him because he had provided me with all the information which made me to understand so in which topics, in which directions, so I can develop myself further, and which future research directions I can choose for myself. And the second one, thanks to the Defense Committee, and thanks to High School of Economics for this miraculous 2 years. So, and without studying here, so I couldn't be here where I am now, so at the University of Zurich. So thank you everyone. So I will appreciate it, really.
Okay, thank you very much, Ivan. That's it. And now, Nikita Ponomarenko, it's your turn. And after that, we will have a short break.
Good afternoon, Professor. Can you hear me well?
Yeah, perfect.
Good afternoon, dear Professor, dear colleagues, and dear committee. I shall present today my work on toxicity detection in corporate environment with the use of natural language processing approach. I will now proceed to sharing my screen and the presentation. Can you confirm that you can see the presentation?
Okay.
Awesome.
Okay.
We can proceed now. So as my topic suggests, it is centered around toxicity detection and with the particular emphasis on corporate messaging and corporate communication. And I use natural language processing techniques and approaches in my work. Why is this problem essential? Why is it quintessential, we can even say, in this time and age? Well, the short answer is that corporate ethics and effective communication are integral parts of any successful business these days. Companies that support and maintain high ethical standards and promote healthy communication are a lot more likely to build trust among their both stakeholders within the company and with the customers, and therefore attain long-term success. And conversely, companies that engage in unethical or immoral practices and let the toxic communication into their internal communication style, they foster the risk damaging their reputation, losing customers in the long run, and jeopardizing their productivity and the bottom line. There might be several reasons why it's crucial for companies to prioritize and ensure these corporate ethics and generally avoid toxicity in communication. The few key reasons include building trust. Companies are generally perceived as trustworthy and good operating within the OSHA and best practices. If they convey healthy communication style, they can attract and retain customers, investors, and employees. Also, we can remark transparency in communication as an aspect of security and reliability. Then there is the term of positive corporate culture. Again, this is largely related to the public image of a company And toxic communication generally leads to negative and hostile work environment. Also results in low morale of the workers, higher turnover rates, and therefore a net decrease in productivity and the quite profound negative impact on the individual employee's well-being. Another aspect is legal and regulatory compliance. Simply, companies that engage in unethical or unhealthy or even illegal communication practices face the risk of regulatory consequences, trials, lawsuits, etc. Or, of course, reputational damage as well. Therefore, it's important, once again, it's paramount for companies to prioritize ethical behavior and to be compliant with the relevant laws. Another aspect is related to brand reputation and the public perception of the company. I have largely discussed that portion. I will not elaborate on this one. Overall, we can say it's critical for the long-term success and sustainability of the business, regardless of the sphere of operations. Corporate toxicity can be channeled through, or expressed rather, through a multitude. Oh, excuse me, I must have missed a slide here. Yes, right here, I apologize. So corporate toxicity can be channeled or expressed through a multitude of means. It may, apologize, if you give me just 1 second, sorry. While we acknowledge the scale of challenges associated with timely toxic prevention, we can treat written communication as arguably the one medium that's capable of toxicity reduction or filtering. This is mainly related to the response time of the moderating instance, because as it happens with within verbal communication, this is largely not reported by the employees to the management, and therefore it does not receive any consequent analysis. While written communication is essentially something that constitutes company legacy that is kept in logs or archived for future reference. Therefore, we can essentially analyze and take preventive measures for verbal and primarily textual toxicity. So the very concept of toxicity is quite ubiquitous, but it is also quite broad and needs to be further contextualized. And as such, toxicity can be generalized at the root level as harmful or negative behavior directed at individuals or groups. Some of the most well-known, omnipresent and abundant forms, I would say, and manifestations of toxicity are cyberbullying, harassment, hate speech, or trolling. Again, this is at the very root level, at the very general level of toxicity. And while the focus of this study is on the workplace toxicity, I will elaborate further on what constitutes corporate toxicity examples. There was a study by Lim and Cortina from 2005, as far as I remember, that extends the list of these forms and manifestations with verbal aggression, for example, swearing, utter show of disrespect, for example, interruption, public humiliation, or ridiculing, and which might be the most discouraging for the employee on an individual basis, the isolation, and most importantly, from crucial work activities, or from communication with other workers, also known as ostracism. Bullying or mobbing at work is also often characterized by a repetitive pattern that is exercised toward an employee or a group. It can be carried out deliberately or intentionally. It can be delivered spontaneously or unconsciously. Regardless of the means and the persistence of this pattern, these actions clearly cause humiliation, offense, and largely distress, and they certainly result in the poor work performance and cause unpleasant working environment for the employee. Therefore, we can summarize the concept of bullying at work as one relating to persistent exposure of one or more employees to negative and aggressive behaviors of primarily psychological nature. We can also further narrow down the definition of corporate toxicity for this area as to negative and abusive language used by employees, customers, or even stakeholders in emails, chat logs, or other communication channels, as well as sometimes setting blatantly unrealistic expectations for the employees, workflows, deadlines, sometimes cases of sexual harassment or suggestive remarks, and just general incivility that make the work environment unwelcoming or demotivating, or even dangerous or hostile to the workers. For the relevance of the issue, and for some notable examples of corporate toxicity of the recent years, we can arguably say that multiple adverse effects of toxic workplace environments can extend well beyond the individual employees and the target, and affect the corporation or the company and global, as well as subdivisions and ruin standing partnerships. I used two notable cases for consideration, the Volkswagen case and the Boeing case. The former relates to Volkswagen engineers tampering with the nitrous oxide emission testing for their newly developed cars. And the company tampered with the diesel engine, specifically emissions. And the actual emissions, when tested out in the field and not in the lab conditions, exceeded the US federal limits up to 40 times, and therefore ruined the compliance with the officially delivered and declared testing results. The company also initially denied having falsified its test, and was finally presented with sufficient evidence by the US Environmental Protection Agency. The issue therefore gained major publicity, and Volkswagen, as a reconciling measure, had to initiate a massive buyback program. It was also subject to about $3 billion in criminal fine. The stock market prices plummeted about a third of its initial value shortly after the scandal, and retained the new price for a considerable amount of time, about several months. One of the notable results was the resignation of the Volkswagen Group CEO, as well as the suspension or firing of multiple top-level executives, both in Volkswagen globally and the US officer responsible for emission testing, as well as $30 billion in fines and civil settlements. Another case that might highlight the importance of this issue even more is the Boeing case, and this is related to the introduction of their new 737 MAX 8 aircraft into service, which was driven by competition with their eternal nemesis, if I say so, the Airbus A320neo, and the negligence of operational guidelines caused by an introduction of a new attack angle leveraging system. The negligence of relaying these operational guidelines to the personnel on the ground, as well as to the pilots, and actually deleting the information about the system from the protocols and from the operational guidelines, led to simple lack of knowledge of how to face the extreme cases of increased angle of attack. And in the long run, it resulted in 2 crashes over the course of the year 2019 of the 737 MAX 8 jets, and 346 lives were taken. Boeing has accordingly suspended all the flights of the new introduced aircraft, launched an investigation in which Boeing was found to dismiss the operational guidelines along with the FAA, which is the Federal Aviation Association, due to accelerated approval of the aircraft, since it was considered, in addition, a remake of the existing model and not introduction of a new one. Boeing also led up to $60 billion in fine. And the key outtake here is that both of these cases are related, even though it might not be evident at the first sight. These were caused by major large-scale toxic management, since they were both driven by competition, and the management essentially tried to impose the tried to impose the accelerated approval rates to drive out that competition and gain a more solid market standing. So just a few words about the mitigation strategies. The workplace toxicity in general is an increasingly problematic issue, of course, for the modern day business, and quenching it can pose a significant challenge. And I've said a few words about the verbal fronts and difficulty in detecting verbal toxicity and responding to it. Therefore, we can only hope for increasing awareness on the side of the management within the company. Well, something tangible is really the prevention of textual toxicity. So for written methods, we can eliminate it or rather try to decrease it by incorporating filtering strategies. This can be done, what's importantly, both in a preliminary fashion and after the interaction already took place. For instance, an algorithm designed for such tasks, it may check the message before sending it to identify potentially problematic or offensive tone found in the message, therefore inform subsequently the sender of the possible issues, and suggest to reconsider the tone or rewrite the message to relay it in a more neutral and conformed way, and therefore prevent the emergence of multiple adverse effects. And alternatively, it can be implemented as a posterior measure, allowing to filter out messages in forums, public discussions, threaded messages, or message boards. And we also have some flexibility in this, depending on the degree of ethical considerations involved. We can either remove, mask, or flag these comments, depending again on the policy taken and on the ethical standing we take. Speaking of the latter one, there are certain moral aspects to be taken into consideration when deciding on a strategy to address the toxic communication at workplace. To summarize it, optimally, we should keep a balance between interpersonal respect, freedom of speech and expression, and effective communication. And ideally, toxicity detection mechanisms should serve the goal of guiding users towards healthier and more productive communication, as opposed to censoring it in a hard way. So for the research questions, the goal was to find out what toolkit is currently available and is used in the corporate environment for addressing toxicity detection. How well do traditional machine learning algorithms fare against more modern and advanced deep learning approaches? Is there a way to reduce bias, including unintentional bias, and overcome the existing limitations of the field? And how adaptable are these models to the realities of different means of implementation, different platforms? Apologize. Right here. Just a few words about the existing solutions. In the recent years, an array of models have been developed to address the objective of toxic content detection and identification. Earlier solutions included naive bias classifications and random forest decision trees, switching later on to recurrent neural networks, such as LSTM, which is long short-term memory, or bidirected LSTM. And the state-of-the-art that I'm going to dedicate a bit more attention to later on is the BERT model, which is the most novel state-of-the-art architecture of the transformer models. I have found a study from 2019 that compares the effectiveness of several models in detecting offensive comments on the Indonesian segment of Twitter. The researchers used a 13,000 tweet dataset. They used naive bias and support vector machines, as well as random forest decision trees. They used hierarchical label arrangement, and they attained the accuracy of about 68% with the support vector machine technique, and tested it on unigrams. This was a major improvement compared to their prior study at about 2.3% increase in accuracy. Another research group demonstrated considerably higher accuracy for 4 data sets dedicated to cyberbullying, offensive language, hate, and sarcasm. And as far to the best of my knowledge, this came from a conference on cyberbullying in particular. They also used Twitter data. They used also glove word embeddings with 200 dimensions and a gated recurrent unit RNN. And the AUC, the area under curve, the ROC curve, showed a remarkable range between 92 and 98%. Well, we can say.
Could you move a bit faster? You have about 5 minutes.
Yes, I apologize for it. My time management could have been a bit better. I can elaborate a bit on the methodology. Basically, the core array of models I had already laid out. So this is basically a summary of these models. Well, I cannot help but address one of the key challenges that is associated directly with the data we process due to its availability, because corporate communication often falls under the non-disclosure policies and therefore is not openly released. One of the notable cases where this principle was violated is the bankruptcy procedure of the Enron energy company in the US. And during the trials, the dataset consisting of about 500,000 employee messages generated through its activity period was either leaked or released publicly, and therefore constitutes one of the most well-known email corps of corporate origin. And this is the dataset I decided to use for my work. There was a quite extensive pipeline for carrying out the work. The original intention, the original pipeline was to use a variety of methods as proposed earlier, of both traditional architecture and more state-of-the-art models, primarily BERT model. And due to several time constraints and computational power limitations, a ready solution was only implemented. And I'll proceed to that part in just a second. I will, if there is enough time left, I will also speak of the standing limitations in the field, because there are many and are resolved with varying efficiency, and I can come back to this topic later on. So the model I used for the study was a BERT model trained specifically for detecting toxic communication called ToxicBERT. And it was offered and implemented as the open source library Detoxify, brought together by Unitary AI. It incorporates a multi-label classification, which is essentially the core of the study, since toxic comment classification, toxic comments detection is essentially a text classification problem. And it gives some flexibility on the results, because we have 6 labels here that range from toxic to severely toxic. Just the division line is in the quantification and the presence or lack of certain stop words. It can also denote a obscene comment, the presence of a threat or an insult, or detect a identity attack when some of the vulnerable groups are targeted by the perpetrator. So the model was tested, the model was trained on the comments of the English-speaking Wikipedia sector, which constitutes about 2.5 billion words. and it was originally designed for Jigsaw Toxic Comment Classification Challenge. And Jigsaw is the subsidiary of Alphabet, aka Google, that developed the one of the modern standards for the area that is called conversation AI, which is also implemented in corporate environment. So the working function of the model is relatively simple. It does all the basic not preprocessing steps, I apologize. It does the tokenization with padding up to 512 tokens, promptly with the BERT model, consistently with the BERT, with the BERT strategy. It does pad it with CLS token in the beginning to mark the beginning of the comment, and it pads the shorter messages to match up to 512 tokens. It does the lowercase conversion where appropriate. It also strips and removes the special characters. It then encodes encodes the token, encodes the tokens, and conducts an inference, then assigns the probability scores for all of the 6 labels, and then normalizes the results with the sigmoid activation function. In some models, there is the GLU activation function used, but in detoxify, sigmoid is the way to go. Due to computational limitations, I could not, after processing, there were about 300,000 emails that were unique and unthreaded. Unfortunately, due to computational limitations, I could not process them all, so I resorted to picking out a random sample of 1,000 messages only, and the results are quite surprising and open to interpretation, as in the resulting random sample, only 2 of them were labeled as toxic, and 1 of them was additionally labeled as obscene. I can actually provide the comments themselves that were labeled as toxic for your consideration. Due to limited time we have, I might just talk briefly about the interpretation, and we can come back to we can certainly come back to those later on, as the appendix suggests. So this is the second comment of the labeled ones, and a lot is happening actually in the first comment. So it definitely exceeds the limit of 512 tokens that are truncated by default by the tokenizer. It is safe that part of this information got lost due to the implicit truncation, and otherwise it could have been a major contributor to the resulting toxicity score. Secondly, the content of this comment is quite likely to represent a threaded structure, a thread of messages, like a series or a chain of messages between 2 people, potentially designated as A and Q in the text. And again, this utters and signifies the importance of precise thread parsing, which was not fully attained in this case, and this is a potential suggestion for improvement of future work. Concerning the text of the message, the model correctly acknowledges it is an example of toxic communication. I'm not sure I can highlight it here, but there was a line saying "stop being so selfish" closer to the end of this comment, and also accusation as in "you are a bad person." But interestingly enough, the model.
Nikita, 1 minute, please.
Sure thing. Does not recognize it as an insult, and also does not recognize the sexist remarks, which should have been identity tag. For toxic message number 2, it was also additionally marked as the obscene message due to presence of several stop words, F words primarily, I assume. And the potential explanations for such results include suboptimal preprocessing steps that I had outlined earlier, most likely related to nested structures, And also just sample being generally conclusive in regard to population, and we could have the alternative approach is to resample it or to bootstrap it. It could also be merely related to low level of toxicity within companies' communication culture and high standards. This is the example.
Okay, Nikita. Nikita, I think we should stop because now we are out of time.
I apologize.
Okay. If you want to add some brief conclusions, you can do it.
I will try to summarize it in a few sentences. I apologize again for taking a bit too much. I would say that the results at this stage are generally a bit inconclusive, and as I've said, resampling strategy would be needed, and prospective studies would include actually fine-tuning approach to the model and experimenting with various lightweight BERT implementations such as distal BERT. And general increase in computational power would be needed because I ran it on my laptop and it simply wouldn't even move past the tokenization stage, no matter of which sort of hyperparameters they used. And of course, the assessment of the model would be needed with some conventional metrics like F1 score, AUC, or a Jacquard index.
Okay, thank you very much, colleagues. Now your questions.
I have a lot of questions, dear colleagues. But the main question is, this presentation would be really very nice to discuss this project if we would be in like September of the last year. So this is the idea of the project and detailed, quite detailed description of what is the toxic, what are the toxic relations at work. And I think the topic is really very much, very important and interesting. But we don't see any, I mean, the analysis that we see is basically, I'm quite speechless, I would say. So basically at work, you just have the description of your data and then nothing else. So now you showed some analysis, but I don't think that this can be these results can be somehow generalized, or you can make some conclusions on them. So this is basically some tests of some models that you made, and I think that the result that you have just 2 toxic messages out of 1,000 is really shows that something is wrong with your model. So I'm a lot confused with this work, and can you somehow I don't know, explain what happened with this analysis part of your project? Was it difficult to get the data? So what was the problem? So why you actually didn't get any substantial results of your project?
Well, I would say there are multiple reasons. First of all, there were some time limitations and general lack of experience in this area, I would say. As for the data itself, it was, as I've stated before in the data segment, it's quite difficult to actually obtain the data due to corporate messages protection and usually the implementation of non-disclosure policies. So this is one of the rare and notable cases of such type of data. And if the opportunity arises, I would actually be quite glad to collect some data, and I would definitely experiment on the multilingual contents, because I feel like there could be regional differences in regards to different perception of the concept of toxicity across different cultures. And therefore, I would love a chance to accumulate some data from, for example, Russian-speaking companies, and therefore obtain data that would test for toxicity in Russian language. Another source of poor results, I would say, I think we can refer to them as such, is the suboptimal performance of the preprocessing step that I've outlined earlier, and namely the presence of largely nested structures like threads, and the parser I had implemented and designed was unable to sometimes scrap these multi-threaded messages into individual emails, and therefore cleanse the data set to the extreme. So a lot of these messages were actually redundant, and sometimes exceeded the 512 token limitation designed by the model. So this is yet another source of inaccuracy. And also this data was contaminated with, I think I actually had a slide somewhere over here. The data was contaminated with messages like this that consisted of nothing but attachments, and this is a factor I only got to know after obtaining my results, and I was looking at some excerpts from the resulting random sample, and this was not accounted for at the pre-processing step as such.
Mm-hmm. But I just want to state that you should understand that at the defense, we evaluate the work which is done, not the intentions. That you are planning to make some research.
Yes, so, I do understand it.
Yeah. Here is a problematic thing. Okay. Thank you, colleagues. You have some questions as well.
Mm-hmm. Okay. Colleagues, do you have other comments or questions?
Yeah, I just have a brief comment. So usually the problem of getting access to some data, it's an important reason to change topic. And usually question of getting the data, it's a question of first half of the year, at least if you are talking about a master thesis, right? And if you're talking about 1 year project. Yeah, and it is a bit strange that you faced with such problem and did not do anything to somehow solve it. Because I suppose it would be possible to get data, or maybe to do something with data which you managed to obtain. You had maybe more time. Yeah, this is it. But I agree that the topic is really promising. It's very interesting, and I would personally love to see some results, because in my company we faced with toxicity in a workplace. But yes, the problem is that it mainly happens in Telegram chats, not on email communication. But it's another topic. Thank you. That's it.
Yeah, I actually appreciate your input. I do fully support the time limitations, I guess, associated with data, and probably the most prompt and appropriate course of action should have been actually adjusting the topic somehow. I found it that this sufficient corpus of data with about 500,000 messages would suffice. I guess it was just a short sight on my end, which I should have discussed obviously with my supervisor, and I should have taken a timely action at that time. I apologize for my shortcoming.
Mm-hmm. Okay, thank you. I think that's it. And as for me, now I'm going to read comments from the reviews. And as for me, I have to say that the work makes an ambiguous impression, and Daria voiced my doubt about the work, and you have made great efforts, but the results have been discouraging a bit. But on the other hand, the work is devoted to an actual topic, and literature review was well done. And otherwise, the model was tested on empirical data. And I think that my suggested grade is 6. And now we have another reviewer, Sergey Davidov. Sergey, could you comment?
Yes, my impression on the work is generally well correlates with the impression of Ivan and colleagues who asked questions. I suppose that the idea of this work is quite promising, and the research corresponds to the approved topic, and the main problem I think is that the results obtained are quite poor, unfortunately. So my grade is 6 good.
Okay, thank you. And now you can, Nikita, you can make some conclusions and your final words.
I would thank you, Professor. I would like to thank you and the committee for highlighting all the praising the constructive points and providing feedback, as well as identifying the potential areas for improvement, and signifying the importance of certain soft skill related decisions I should have taken. I really do appreciate it, and I would also like to thank all of the staff at HSE and the ANR-Lab that made this this journey possible, and for all the things that I had outtaken, both in terms of knowledge gained and hard skills, as well as again potential areas of improvement in terms of soft skills and communication, and just a really deep human thank you. It has been an amazing journey. Thank you so much.
Oh, sorry. Okay, thank you. That's it. Your defense is over, and now we are going to make a short break. Not so short break. We are going to make a break, and your final grades we will sound after the second part of our students, after the defense. And I think it might be, it's around, wait a moment, I'll check. Yeah, I think it might be 6 p.m. Yes, okay, that's it. And dear colleagues, may I ask you to leave, to stay here for a moment?
Да, я сейчас коллег, как раз студентов, отправила в зал ожидания. Да.
Окей. Давайте тогда подведем итоги.
Ну, наверное, надо запись остановить.